Hi everyone, my name is Furkan-Yesiler, and today I will give you a high-level overview of my PhD research. Its title is Data-Driven Musical Version Identification, Accuracy, Scalability, and Bias Perspectives. My supervisors are Joan Serra and Emilia Gomez, and the secondment for this project is BMAT from Barcelona, Spain. My talk today will have three main sections. First, I will motivate our research. Then I will briefly give an overview on the scope and the main objectives of this project. And lastly, I will talk about what we have been doing these last 3 years by going over our contributions. So let's begin with the motivation. I would like to start with a quote from Emmylou Harris. Songs need new voices to sing them in places they've never been sung in order to stay alive. Creating versions is an essential part of musical practice. As Emmylou Harris puts it very delicately, creating versions helps songs and compositions to stay alive for many decades or even centuries. And in fact, before the advent of recorded music, listening to a piece of music mostly meant listening to a version of it, in many cases performed by artists other than the original composer or the performer. Some of these versions are reproduced very faithfully with respect to their originals, mainly to honor the original composers or the artists, but also some versions include many stylistic and artistic changes, and they show us how an existing idea can be transformed into something very different while keeping their roots connected to the original pieces. But however they are created, versions are a fundamental part of the world's musical heritage. And by definition, versions have to incorporate some differences between them. But humans are extremely good at looking past these differences and at identifying versions. Actually, this is due to a skill that is required for our survival. It's the skill of categorization. We form internal categories to understand the world around us. When we see an object, we don't just consider that as a completely unique object. We perform some subconscious similarity computations with that object and the objects that we know, and then we categorize the things that we see. We come to the conclusion that that object is a table, or is a door, or is a dog, or these sort of things. And as a byproduct of this skill, we can also understand if if a song is a version of a song that we already know, by performing these kind of similarity comparisons. And if they exceed a certain threshold, certain similarity, let's say, then we come to the conclusion that, okay, this song that we're listening to now is a version of a song that I already know. But although this is a byproduct of this more like general categorization skill, being able to identify versions is valuable to us. When we listen to a version of a song that we already know, our brains are stimulated from two perspectives at the same time. At the same time, we hear something familiar and also novel. And because we hear something familiar, we form some expectations in our brain. And these versions fulfill these expectations. We kind of guess what the next notes or the chords or the lyrics are going to be. And when these expectations are fulfilled, this plausibly affects us in a positive way. But also at the same time, we hear something novel. This is a different version. There are some differences. And these novelty surprises us. And these both the familiarity and novelty aspects give us a pleasurable listening experience. But also having an intuitive understanding of this concept of versions helps us to discuss concepts like musical plagiarism or musical copyright in an easier way. Because since we have an understanding of the similarity between songs, we can talk about what constitutes a unique song or what constitutes a version. how similar two tracks should be for us to be consider them as versions or not. So humans are pretty good at identifying versions, but still building automatic systems for this task is highly useful as well. Such automatic systems can be used to detect musical plagiarism or copyright infringement cases in media platforms or streaming platforms. Especially today, when the amount of new content is getting larger and larger every day, it is impossible to handle the licensing aspect of this new content manually. So basically, we need automatic systems to make sure that we protect copyrights of like artists and composers. Also, I just talked about how listening to a version is a valuable experience for the listeners. So that's why we can also use these automatic systems for music discovery and music recommendation to give listeners a more plausible listening experience. Also, with these automatic systems, we can perform some large-scale data-driven musicological analysis, and maybe we can reach some conclusions that we couldn't have reached with working with only small-scale data. And lastly, these automatic version identification systems can also be used in the artistic process of musicians. For example, when a musician creates something, we can automatically quantify how similar that creation is to the existing pieces of music to notify the musicians if they are on the verge of plagiarizing something or not. Because as we all know, sometimes you hear a melody from somewhere, but you are not actually sure if you heard it or if you came up with it yourself. And this would be an easy way, an automatic way to be able to notify musicians in these sort of cases. And now that we kind of established why versions are important and why studying versions is important, and also why building automatic systems is important, now I will briefly go through the scope and the objectives of this project. As you all know, the reason why we're here is that we're at the MIP-Frontiers workshop, and this project is a part of the MIP-Frontiers. And as Simon just went through the objectives of this project, one of the main objectives is to encourage collaboration between academia and the industry, and to make sure that, let's say facilitate that the outcomes of the academic research can be used in industrial applications, so that they can have a larger impact. So because of this, the main objective of this project, of our project, is to develop automatic version identification systems for industry scale corpora, for industrial use cases. When we first started this project, the existing version identification systems were struggling with accuracy scalability trade-off. The systems that were performing very good were very slow, and the fast systems could not give reliable results. And at the same time, in the general MIR community, there were a lot of research going on with the data-driven paradigm, especially with machine learning or deep learning research. So by looking at this landscape, we decided that the next generation of version identification systems must adopt a data-driven paradigm. So then we start to develop data-driven models for version identification. But if we want to use these models in industrial context for industrial use cases, we thought that we have to address three main aspects. First, these systems should be accurate enough, should be reliable enough to not fail their users. Second, these systems should be scalable, so then they can process corpora of millions of tracks very easily. And third, if we are going to use these systems in industrial context, we need to be aware of any bias that they may inherit, if they favor certain artists over others or not. Because if we are not aware of these, we may create some unfair situations when we actually use these systems in real world applications, like in streaming services or media platforms. So that's why we decided that the three main aspects we are going to focus on were accuracy, scalability, and algorithmic bias. And lastly, I will go through our contributions. So in this thesis, we first provide a discussion of the concepts of musical version and musical work from MIR, musicology, and legal perspectives. In the previous work, there were some mention of how these concepts are defined in the musicology as from a musicological aspect, but there was not a discussion in depth. And we think that it's important to understand how these concepts are defined in different contexts, because actually these are related contexts. We're not talking about different things. Of course, in practice, they may have some other practical uses, these terms. But in the end, although we try to create automatic systems, this is mainly an interdisciplinary field of research. So we should understand how other researchers, how other scientists think about these concepts as well. Secondly, we provide a survey of key ideas, techniques, datasets, and evaluation methods from 2 decades of version identification research. Until this, the last such survey was from the year 2010. So there was like a gap of 11 years, more or less. And we want to combine also and compare the latest data-driven systems with the already existing knowledge-driven systems. And with a great collaboration with 4 other authors, we published the result of this survey, basically this survey, actually we will be publishing it next month. It will be published next month at the IEEE Signal Processing magazine. Third, we performed the first large-scale quantitative analysis on the frequency and the extent of changes between versions. So we all know what kind of musical characteristics may be different between versions, but there was not a large-scale analysis on how frequent these changes are, or to what extent we can observe these changes. For example, if we know that the key of a song can be different between versions, but until how many semitones can this key be different or not? So we wanted to see these things, so then when we want to build our own systems for version identification, we can put more emphasis on the more common changes and also more drastic changes. And the result of this analysis was published at ISMIR 2019. Our fourth contribution is a novel data-driven version identification system with explicit musically motivated modules for handling the common changes between versions. So using the results from our quantitative analysis from the previous contribution, we started to develop our first data-driven system, and we designed explicit modules to handle these common changes and the more drastic changes between versions. So in a way, we could say that we somehow incorporated knowledge-driven design decisions into data-driven workflows. And at the time, the system that resulted from these experiments that we call MOVE, it was the state-of-the-art system, and we published the results at ICAST 2020. So MOVE was state-of-the-art back then, but as I said earlier, we had to further address 3 main perspectives: accuracy, scalability, and algorithmic bias. So we first started with the scalability aspect, and we performed a comparative analysis of embedding distillation techniques. And we demonstrated speeding up in the retrieval phase of version identification systems. So these embedding distillation techniques try to improve the scalability of existing models without compromising their accuracy. So then this is a way of further emphasizing the scalability of these systems. And the result of this analysis of these experiments was published at ISMIR 2020. So next is the accuracy aspects. And although MOVE was state-of-the-art back then, of course, there came better models. and we wanted to further improve its accuracy. So for that, with researchers from IRCAM, we analyzed some data-driven ensemble approaches for version identification by combining systems that process complementary musical information. Move, although it was a great model, it's only processed harmonic information from audio signals. And we combined Move with another model that processes melody information to create these ensemble systems. And then we saw a huge increase in accuracy as a result of this ensemble investigation. And the result of this research was also published at ISMIR 2020. Our seventh contribution is that we performed the first study ever to investigate the algorithmic biases of version identification systems. And we used 6 relevant attributes like gender or popularity, etc., of musicians or tracks. So what we did basically was we wanted to see if our models, the models that we developed, favor some artists, for example, some male artists over female artists, or some popular artists over not popular artists, and so on, to be able to see if we really use these models in industrial context, if we would create any unfair situations or not. And the results of this this analysis will be published at the Wisdom conference next year. And actually, we just heard that it was accepted 2 days ago. So it's also a recent news for us. And the 8th contribution, we studied the efficiency of our systems for industrial use cases in collaboration with BMAT, our secondment and the industrial partner of this project. We first wanted to assess our models for identifying the musical content in long audio tracks of live music events like concerts and so on. And this is a real use case of BMAT, for example, trying to identify the songs in a concert, in a festival or something. So we created a data set and we assessed our systems for this specific use case. And also we performed a large-scale retrieval study using a corpus of nearly 1 million tracks. So we said we needed to have accurate and scalable systems. So we wanted to see if these systems that we develop really work with a corpus of hundreds of thousands of tracks. And the results of the first sub-contribution was published at ICASP 2021. And lastly, we provide a critical discussion on the current open issues and challenges of version identification systems from both academia and industry perspectives. And this discussion is also part of our article from IEEE Signal Processing magazine. Here is a list of all of our main contributions that I just went through. But apart from these, we also created 3 publicly available datasets. We created a benchmark suite for reproducibility purposes. We created 4 open source repository for our models. All of our code, except for 1 paper, is available online. And as a result, we have 1 journal paper and we published 6 peer-reviewed conference papers. That's all from me. I would be happy to answer if you have any questions.